I thank management, HODs, professors, and faculties who supported us and given a permission for conducting this webinar. Myself, Mohammed Akmal, sir has been given a brief introduction about me. Without further wasting the time, let's start our webinar. I will be engaging with you for next 1.5 hours. What we will be discussing, we will be seeing a short introduction about Siemens, importance of PLC, various layers of automation pyramid, introduction to Industry 4.0, impact of Industry 4.0 on manufacturing industry, solution from Siemens for Industry 4.0, training on latest technologies provided by Citrain. Then we will have fun quiz followed with technical quiz. The winner of the technical quiz will have some surprise from Siemens. Siemens is a German-based MNC company which has presence in more than 190 countries. It is founded by Werner von Siemens, who had a dream of founding an enterprise of world standing comparable to that of the Pagad dynasty. Siemens' relationship with India has been begun very long back in 1867 when Siemens started laying a 11,000 kilometer long Indo-European telegraphic line between London to Calcutta. Before this telegraphic line, the messages were taking more than a month to reach. After this telegraphic line, we are able to receive the messages within less than half an hour. To be precise, 28 minutes. I would like to play a short video about Siemens, which will explain various industries in which we are present and what are the solutions we have been providing for the various verticals.
Every night, 1,200 million Indians go to sleep, hoping for a better tomorrow. Every morning, we get them a step closer. We are Siemens, a global conglomerate spread across 190 countries of the world. Our partnership with India began 150 years ago and continues to grow from strength to strength as we add pages to its story of success. We help to keep India running by meeting her growing power needs. Siemens has installed energy systems around the country to ensure the efficient generation, transmission, and distribution of electricity. With smart grids in 8 cities in Maharashtra, we have provided 20 million people with the power they can rely on. We're helping the country's lifeline. The railways conserve 30% energy. That's 500 million rupees saved every year. And continues to grow from strength to strength. As we add pages to its story of success in the country, uses Siemens Technologies. To help the nation reach new destinations by meeting her growing new power needs. Siemens has helped revolutionize the urban transport system. Siemens has installed energy systems around the country to ensure the efficient generation, transmission, and distribution of smart cities. With smart grids in 8 cities in Maharashtra, is the driving force behind India's manufacturing success they can rely on. We're helping the country's sectors and brands, the railways that propel the economy to new heights, energy are powered by 500 million rupees saved every year to grow from strength to strength. As we add pages to every story of energy in the country, uses Siemens Technologies made by Siemens. On Indian roads, 1 out of 2 vehicles run on engines made using Siemens technology. With a goal, we have reached more than 70% of shipment handling power needs. Benefit from Siemens has helped revolutionize the urban transport system. Installed energy 3 out of 5 machines that make energy efficient generation. We have laid the foundation. 85% of steady plant gained from Siemens solutions. With ensure purity in 8 cities in Maharashtra is the driving force signaled as manufacturing success. They can rely on Siemens. We are committed to building a healthy India. We're helping the country's life sector and railways that propel the economy to new energy systems are powered by 500 million technologies. Saved every year to make accurate tracks and have touched 3 millions of lives to power the energy in the country. Siemens established the world's made by lab automation track at Coimbatore in Mumbai. Enabling road that 100,000 run on engines made every using Siemens technology. With a goal state-of-the-art more than run mobile shipment handling power health benefit to Siemens has helped revolutionize the urban transport system. Installed energy 3 out of 5 machines that make energy efficient generation. We have laid the foundation to smart communities. One which has grown from CBM for 600,000 villages in Maharashtra. The driving force signaled as manufacturing success. They can rely on Siemens. We are committed to building a healthy and digitalization the country's life sector and railways that many more new energy. India's powered by 500 million rupees. Saved every year to make accurate tracks and have touched 3 millions of lives to power the energy in the country. Siemens established the world's made by lab automation track at Coimbatore in Mumbai. Enabling road that 100,000 run on engines made every using Siemens technology. With a goal state-of-the-art more than run mobile shipment handling power to Siemens has helped revolutionize the urban transport system. Installed 3 out of 5 machines that make energy efficient generation. We have laid the foundation to smart communities. One which has grown from CBM for 600,000 villages in Maharashtra. The driving force signaled as manufacturing success. They can rely on Siemens. We are committed to building a healthy and digitalizing the country's life sector and railways that observe our new energy. India's stored by 500 million rupees. Saved every year to make accurate tracks
most of the
and have touched 3
metros
millions of lives to
in
power the energy in the country. Siemens established the world's made by lab automation track at Coimbatore in Mumbai. Enabling road that 100,000 run on engines made every using Siemens technology. With a goal state-of-the-art
Now
more
coming
than
back to the
mobile
other
shipment handling power
fair idea
to Siemens has helped revolutionize the urban transport system. Installed 3 out of 5 machines that make energy efficient generation. We have laid the foundation to smart communities. One which has grown from CBM
food and very
smart
kind of
villages
and
is the driving force signaled manufacturing success. They can rely on Siemens. We are committed to building a healthy and digitalizing the country's life sector and railways that observe our new energy. India's powered by 500 million rupees. Saved every year to make accurate tracks and have touched 3 million lives to power the energy in the country. Siemens established the world's made by lab automation track at Coimbatore in Mumbai. Enabling road that 100,000 run on engines made every using Siemens technology. Goal state-of-the-art more than run mobile shipment handling power health to Siemens has revolutionized the urban transport system. 3 out of 5 machines that make energy efficient generation.
Automation layer, we will be having a SCADA system and energy management system. In SCADA system, it will help the operator to know the status of the equipment, whether this motor has been running or it has been off. That information can be known to the operator or can be visualized by the operator using the animations over here. For an example, if this particular motor has been running, we can make animation as something has been rotating in a red color. When this motor is been off, we can make it as a standstill in the green. So it will be very easy for the operator to know the status of the equipment, whether it has been on or off, whether it is valves has been open or closed, like that. Then energy management system, it will help us to know the transparency on the energy consumptions, which machine is been consuming how much power, which production line is running efficiently. So all the data related to the energy management will be available in the energy management system. The top of it, we have a management layer where manufacturing execution system will help the top management by providing the dashboards of what is happening and inside of the shop floor, like what is the production plan for today and what is the actual production going on now, how many workers are being there in the shop floor now, what is the cost of the production. So all these informations required for the top management will be available in this manufacturing execution system. Then the top layer, we have it product lifecycle management, where the product design, product data management, production planning along with the ERP systems will be connected to that. From Siemens, for parameterization of field layer, control layer, operation layer and management layer, we have a software called totally integrated automation. In short, we call it as an TIA, TIA portal. So apart from having the parameterization and controlling of this device, there are additional tasks which is been intended to be by the automation, is like integration of the safety. It's not only the safety of the human being, it's in safety of the machineries also. So whenever we make any automation, we can include all the interlocks in such a way that unless otherwise those interlock has been fulfilled, the machine will not able to switch on or operate. Then industrial security, which is nothing but the cyber security. Nowadays, you might have been heard that we are getting a news as cyber attack has been there for 10 to 20 minutes. It has resulted in the crores and crores of financial losses. So that's the huge impact what the cyber attacks has been able to making damage to the organizations or the industries. So most of the industrial security are taking a stringent actions, which is nothing but the cyber security. Nowadays, you might have been having a proper we are getting a news as cyber attack has been industrial communication. It has due to pandemic, industry people like us were working from home. So even the huge impact classes for the colleges and schools has been conducted. So most of the industrial security because of actions, communication, for the cyber security. Nowadays, you are not able to follow or you are able to hear what the speaker is cyber attack has been industrial communication is in place due to pandemic buffering and you are not able to follow it. Just imagine a similar situation happening in a production plant. Because of communication interruption, if the operator from the SCADA room is not able to know the status of the equipment, whether my motor has been on or off, whether my drive is giving any alarm, what will you just imagine what will happen if the operator doesn't know the status of the equipment? It may lead to the accidents, damage, breakdown, even it may be danger for the life of the operators also who are in the field. So to have a robust and stable communication in industries, we have a dedicated hardwares and softwares to have a robust and stable communication network. Industrial data management breakdown, even it may be right information for the right people, like for the right operators also who are in the field. So authorizations. To have a robust and stable communication, the personal details of the employee should be accessed only by the HR. To similarly, production details like how much raw material I have, what is my production plan for today, how much finished products available in my storeyard. So all this information should be accessed only by the production department. What will happen if this data is been accessible to everyone? There might be a chances that people may misuse it, which will lead to a reputational damage and financial losses for the organization. So we should have a proper data management with hierarchy and authentications. Integrated engineering. In any plant, there won't be a single make machineries working standalone, right? There will be several make machineries working together to make a finished product. To have a seamless and smooth operations of these machineries, we need to have a proper integrations of that. So these are the additional tasks which has to be taken care when we are making the automation architecture for any of the industries. In any plant, there won't be a single make machineries working standalone, right? There will be several make machineries working together to make a finished material A and material B. To have a seamless and smooth operations of these machineries, we need to have a proper integration of that. So these are the additional tasks which has to be taken care when we are making the automation architecture for any of the industries. In any plant, there won't be a single make machineries working. Go for a manual control where I will have machineries working together to make a finished material A and material. To have a seamless and smooth operations of this filling up to the level. We need to have a proper integration of wall to material. So these are the additional tasks and ensure that material which has to be taken care when we are making the huge automation architecture in any plant, there won't be a single make machineries working. Go for a manual control where I will have an operator where I will open the material A and to have a seamless and smooth operations of filling up to the level. To have a proper integration of wall to the. So these are the additional tasks and ensure that material which has to be taken care when we are making the huge automation architecture in any plant, there won't be a single make machineries working. Go for a manual control where I will have an operator proper and will open the material A and to have a seamless and smooth. The overall reliability of the system will be very low, and even during any troubleshooting it will be a tedious task for us to find out where is the root cause of the problem, because there will be several wires going here and there, which will lead to the more breakdown time, which will the overall reliability of the system timers will be replaced by the electronic logic gates like AND gate, OR gate, for us to find out where is the root cause of the problem, because there will be several wires going here and there. Change the sequence of your operation, which will lead to maybe instead of two materials, if you want to add one more material, tedious task, or even sometimes you may have to replace a new controller itself for the new requirement. So all the drawbacks of manual control, hardware relay logic control, and dedicated electronic control can be overcome when we are using the PLCs, programmable logic controller. PLC consists of input modules, CPU along with program memory area, then output module. Input module and output module are used to connect the field hardware devices and control and dedicated. So if you take our example using the PLCs, when I press the start push button, I wanted the valve V1 to PLC get open, right? So I will connect my start push button over here, so that when I am not pressing the start push button, this positive 24 volt will be available up to this point. So as soon as I press the start push button, the circuit will be closed and this positive 24 volt will be applied to the input terminal here. So each input terminal and each output terminal will have a dedicated assigned address, memory addresses. So whenever I get a positive 24 volt at this point, the CPU will sense that as a signal at that particular input. Then I can write my logic that whenever I get an input here at this point, at this address, then make this output address as an high, so that it will open the valve V1. In this webinar right now, we are not discussing about how to write the PLC program because it is a vast topic, and maybe in future webinars we will try to cover it. But at least now, as of now, for time being, you just understand how the PLC is being used to make a process to run automatically. Now I have pressed the start push button and my valve V1 has been opened. Now material A will be getting started filled, right? So once it reaches up to the level L1, there I have a limit switch whose NO contact will be getting changeover. That limit switch NO I will be taking as an another input. So as soon as the material A reaches to the level 1, this NO will be getting closed and circuit will be closed. I will be getting a positive 24 volt at this input terminal, which will be sensed by the CPU as I have got a signal that level 1 has been reached. So whenever the level 1 has been reached, I will be writing a PLC program in such a way that I will be opening the V1 and closing the V1 and opening the V2. So once material A reaches up to the level 1, I will be closing the V1 and opening the V2. V2 will be connected to the output module, and this L1 limit switch will be connected to my input module as an input to the PLC. Now V2 has been opened, so material B will be getting filled, and once it reaches up to the level L2, then there another limit switch is there whose NONC contact I will be taking as an input to my PLC, and I will be writing a PLC logic in such a way that whenever I get a input from this limit switch, close the V2 and switch on the motor. Now my motor will start rotating, and it will be mixing the material A and material B. I can use the external timer or inbuilt feature timer feature of the PLC to monitor the time. For an example, let's say half an hour. So once the half an hour is been over, I can take that as an input to my PLC, and I will be writing a logic to stop them whenever I get a input from the timer. I will be switching off this motor and opening the V3. So once V3 has been opened, my drained valve, the mixed product will start getting flowing and it will be getting drained. And once it reaches to the lowest level L0, there the limit switch is there whose NONC contact again I will be taking as an input to my PLC to close the V3 and open the V1. So the process, once I press the start push button, first time V1 will be getting open, material A will be getting filled, and once it reaches to the L1, sense level L1 will be sensed, V1 will be closed and V2 will be open. Then material B will be getting filled, and once it reaches to the level L2, it will sense level L2. Then V2 close, motor on. After the time period, half an hour, motor will off, and V3 will be open. Once material started getting drained, once it reaches to the lowest level L0, that will be sensed to close the V3 and open the V1. So now my process has started running continuously automated unless I press the stop push button. You may be thinking that what's a complex in this, because just when I press the start push button, I need to open the V1. Once I get a signal from the L1, I need to close the V1 and open the V2. It seems to be simple, but in real industries, it will be not as simple as what we have seen now, because there will be hundreds of applications, thousands of inputs and thousands of outputs for taking one action itself. For example, for closing the V1 itself, we may have more than 20 to 30 inputs or status or signals we need to check. Similarly, for switching on one motor, we need to check more than 20 to 30 parameters or 20 to 30 inputs from the field. Apart from writing our own control logic as per our requirement, we can use some more features of the PLCs like timer, which can be used as an on delay timer, off delay timer, impulse timers. We can use the counter features for up counting and down counting. We can use it for any counting applications. Processing of analog signal. For an example, if you have a boiler and you want to know the temperature of the boiler continuously, which will be keep on changing every second. So that kinds of signal which will be keep on changing every second, that we call it as an analog signal, and we can able to process such kind of analog signals also. Then PID controller, arithmetic functions like addition, subtraction, we can able to add two signals or add two values. PLC can be used to communicate with other controllers like HMI, IPCs, even other PLCs also. It can be used to integrate HMI from where the operator can able to control the machine from remote. He no need to go to near to the machine to press the start push button. He can press the start push button from the HMI itself, so the process can be started. Signaling and listing. If you take our example, what we have seen, there is a sequence of event. Like when I press the start push button, first V1 should get open. So material A will be getting filled, and then L1 should reach. I should get a signal from the L1. So there is a sequence of event how the my process should work. So when we have this kind of signals more than 1,000 or something, it will be very difficult to monitor whether it has been happening sequentially. So in that case, PLC, when we are using the PLC, we can very easily able to monitor whether my I am getting inputs and whether my outputs are being getting operated as per the sequence of my operations. So the signaling and listing of the inputs and outputs can be easily done. Real-time functions like date and time. For an example, instead of I going and pressing the start push button or switching on the machine from remote through HMI, I can write a logic in PLC such a way that every day morning 9 o'clock, my V1 will get open. So my process will be getting started running continuously. So that kind of time and dates or real-time functions also we can able to use it in PLC. When we use PLC, we save on space, we save energy. It's easy for maintenance because during troubleshooting, we will able to find out where is the root cause within few clicks. So it will save your time during your breakdown, and it will help us to resume your production as early as possible. It's economical when compared to the hardware relay logic control. It gives long life and reliable. It gives flexibility for you to change your control logic at any point within few clicks. For example, if you wanted to add a third material, we can able to add it very easily. Because of this, your overall project time will be getting shorter, and you will able to have a better archiving and documentations of the data. Just comparing our application with our automation pyramid, the field devices like valves V1, V2, V3, limit switches L0, L1, L2, all will be categorized as an field layer devices. Then PLC and HMI will be control layer devices, and if you are using the SCADA, then it will be a operation layer devices. So our pyramid will be have only 3 layers for our application right now, whatever we have seen. So up to this point, I take a pause and I will enable the mic for the all the attendees. So if you have any questions right now up to this point, you please feel free to ask and get it clear. Now, up to this point, we have seen if there is an application, what are the different options I have to fulfill my requirement, out of which how PLC is being used to make the process to run automatically, and what are the features of the PLC and advantages of the PLCs. So I have enabled the mic option to you. Please unmute only if you have a questions. Otherwise, please stay in muted. Okay, I will take this silence as there is no questions now, and we will move ahead. You will be agreeing with me that we are living in a digital world. Our gadgets are becoming smart. Our home appliances are becoming smart. Even the cities we are living are becoming smart. On screen, you are seeing few businesses which has changed the way how it used to worked before. Nowadays, most of us are not going to the libraries because we have most of the books in ebook format, which we can able to access, read it at our own convenient time and place. Those days are gone when we used to buy the cassettes and play it in tape recorder and DVD player. Even after playing few times, the video and audio quality will be getting deteriorated. Thanks to the online streaming apps, even if you play 1,000 times, the audio video quality doesn't get affected. We have been moved from yellow pages to the marketplaces. We have moved from taxis to the online transportation network like Uber and Ola. I hope most of you have been used these applications, right? Online transportation network. How easy and convenient it is. Like whenever I book any taxi, I will be getting information which vehicle is going to come, what is the contact details of the driver, at present where is he, which way he will be reaching to my place, how much time it will take for him to reach my place. So all these informations are available on my phone itself. So I can, based on this information, I can guide him if he is going in another route, or I can able to plan my other activities. Just imagine what is this digitalization has created, or how it has changed the way how the industries used to work before. The answer for that is industry 4.0, the latest industrial revolutions. Have you heard this word industry 4.0 before? Okay, because your mics are muted, I'm not able to even hear if you say no also. So maybe for the persons, or the for whom has not heard about the industry 4.0 before, I would like to play a short video which is made by Siemens in 2013. We have used one small application to demonstrate what is industry 4.0 and how it's going to work. As I said, this video is been made in 2013, almost 8 years back. That time in this video they would be mentioning that it will take 20 years to become this as a reality, but now within 10 years itself we can able to see many of the industries are implementing industry 4.0. Just try to pay attention to what they are saying, then once the video is been over, I will explain you in detail.
A vision of tomorrow's manufacturing.
Bhunesh, can you confirm, are you able to hear the audio also?
Yeah, the video is fine. You can go ahead.
Okay, thank you. Thank you.
A vision of manufacturing that's finding their way independently through the production process. In intelligent factories, machines and products communicate with each other, cooperatively driving production. Raw materials and machines are interconnected within an Internet of Things. The objective, highly flexible, individualized and resource-friendly mass production. That is the vision for the fourth industrial revolution. A look back at history. At the end of the 18th century, the first steam engines and the intelligent use of hydropower revolutionized production. The late 19th century saw the rise of electrical engineering and mass production. The first moving belt conveyor was used as long ago as 1870 in the slaughterhouses of Cincinnati, Ohio. In the mid-1970s, electronics and IT began to expand rapidly into industry. Siemens developed the first SCADCET. Production became increasingly based on computer-assisted controls. The fourth industrial revolution is still a vision. Experts believe that it will only become a reality within the next 20 years. In intelligent factories, everything is interconnected wirelessly. At the German Research Center for Artificial Intelligence in Kaiserslautern, this future can already be experienced right now. Research is underway here into exactly what the industrial production of tomorrow will be like.
Fabriken werden zukünftig aus Bausteinen bestehen, aus smarten oder intelligenten Bausteinen, wie man es nennen mag. Vergleichen wir das vielleicht mal so ein bisschen mit einer Lego-Steinwelt. Das heißt, wir haben standardisierte Bausteine, die wir hoffentlich relativ einfach zusammenstecken und zusammensetzen können. Jeder dieser Bausteine hat bestimmte Funktionalitäten und wir können sie zukünftig in einem solchen fabrikinternen Internet dann kombinieren.
A bottling plant for liquids, set up together with Siemens, is used to demonstrate the most important components of the intelligent factory of the future.
Each bottle contains an RFID chip storing a precise description of how it has to be processed. Which liquid, which lid, and which label. At each station, the bottle communicates directly with the machine, telling it how it has to be processed. At the end, a computer checks whether the bottle has actually been produced as desired. Factories with networked machines and products are already in existence today. In the future, however, these hitherto self-contained systems will be connected together in a comprehensive network. All devices, machines, and materials will be duly equipped with sensors and communications technology and connect to each other. These systems are known as cyber-physical systems. The highlight is that they communicate and also control each other cooperatively.
Wenn Sie sich das Thema Industrie 4.0 angucken, dann basiert sie ja auf der Logik dieser Cyber Physical Systems. Das heißt, Sie haben autokrate selbst arbeitende Systeme, die sich optimieren und sich gegenseitig austauschen und dadurch letzten Endes Produktion optimieren.
Ja, die Vision sieht so aus, dass wir ein Internet quasi hinunterziehen bis auf die unterste Ebene. Das heißt, jeder Sensor, jeder Aktor wäre damit quasi ein Teilnehmer eines Internet der Dinge. Jedes Gerät hat damit eine eigene IP-Adresse, ist damit adressierbar in diesem Netzwerk.
For the customers, this means tailor-made products at relatively affordable prices. For industry, it means highly flexible mass production that can be rapidly adapted to market changes, because in the future, product life cycles will be even shorter. Another reason why it's increasingly important to depict engineering across the entire life cycle. Maintenance, for instance, is planned in from the very start.
Wir haben ja bereits in den 90er Jahren mit Totally Integrated Automation entsprechend ein Setup gewählt, wo unsere Produkte und Systeme sehr gut miteinander kommunizieren können.
At Corporate Technology in Princeton, a cyber-physical control is being researched even today. The vision, the control, and all linked sensors are connected to the Internet.
One potential scenario is enabling the PLC to react to utility pricing information in building automation. We can enhance PLCs to use simulation to calculate how much to pre-cool a building with the ultimate goal of turning off the cooling system during peak times.
But that's just the beginning.
We've prototyped capabilities in a PLC to access big data in cyberspace in real time. And we've also enabled a network of PLCs to connect to a dynamic simulation of the entire physical process.
Siemens is shaping the future of industry. Connecting the real with the virtual world of production is making it possible to enter entirely new dimensions in quality, efficiency, and flexibility. The company is well prepared for Industry 4.0.
I hope now you are gotten fair idea about what is Industry 4.0 is, right? In Industry 4.0, the devices will have the capabilities to get connected to the internet. They will have the capabilities to communicate with each other and control the process automatically. As shown in the example, in water filling, they have taken a water filling plant. In water filling plant, they have using the RFID chip, and that RFID chip will contain all the information like which liquid need to be filled, how much quantity, which cap to be placed, what sticker to be pasted. So all these informations related to the productions will be pre-programmed in the chip, and the chip will be placed on the bottle. As the bottle goes, it will machine will automatically fill the liquid or fill the as per the quantity mentioned, and it will put the cap and sticker. Just imagine if you take any beverage, any soft drinks, there won't be a single brand coming from the single there won't be a single soft drink coming from the single brand, right? They will have various variants or various products. For example, if you take Coca-Cola, they will have Savana, Fanta, other things. So the industries doesn't require a different bottle filling plant for different liquids. What they can do, they can place the chip on the bottle, and as the bottle moves from one stage to another, automatically it will decide which soft drink needs to be filled in that bottle. So by this, the companies can save a huge cost and they can utilize their resources very effectively. The point to be highlighted over here is that whenever a new industrial revolution happens, the skill set, the technical skill set it requires also changes. For an example, during first industrial revolution, when the people started using the steam engines by replacing the animals, there has been a huge demand for the repair shops of the steam engines. In second industrial revolution, when they started using electric motors and used conveyor belts for producing the mass production, standardization and process knowledge was much needed. In third industrial revolution, when they started using the PLCs and computers started industry started using the computers and IT was in boom, softwares and their updates were much needed. Now in fourth industrial revolution, which we call it as in cyber physical systems, as the devices will be capable of connecting to the internet and capable of communicating with each other, we will be getting lots and lots of data from the devices. By analyzing that data, whether it has been good or bad, we can able to take actions or corrective actions. So that's why we call it as an now we needed data driven services. Apart from the first industrial revolution, all other industrial revolutions are interconnected. Means unless otherwise you implemented the previous industrial revolutions, we cannot able to move ahead with the latest industrial revolution. When people started using the electric motors by replacing the steam engines, during that era we can call it as an electrification, because during that time they were using the components which can controlled electrically. Then they started making the process automated. They started using the PLCs to control the machines, to control the process run automatically. That era we call it as an automation. Now in fourth industrial revolutions, from where we will be getting a lots of data from the PLC systems, by which analyzing those data we will be taking actions, that we call it as a digitalization, which is the next level for the productivity. As per the recent survey or study, even most of the Indian industries, more than 50% still are in manual control or semi-automated. So there has been a huge scope for the automation in India at present. If you take any process plant where the field layer devices, if you able to recollect or remember the automation pyramid slide which I have shown previously, these are the field layer devices, right, which will be connected to the control layer devices and operational layer devices via industrial communication network. So there they will be having some common questions like how to turn my data into information, how to realize and maintain the digital infrastructure, how to ensure consistent data in engineering and operation, how to connect all devices safe and secure, how to reap the benefits of fully integrated workflows. In short, how to implement the industry 4.0 in industries, or how the industry 4.0 works. Industry 4.0 is not a single technology. It consists of various latest technologies like mechatronics and robotics, RFID, remote control system, and predictive maintenance. Nowadays, most of the industries have started using the robots, which can work along with the humans to produce the products fully automated. When we are using the robots, they work around the clock. They no need to take a break or vacations. They no need to. They will be not getting sick or tired. Their quality will be consistently, because we require the less human resources or less intervention of human labors. We can save on the labor cost. When we say robotics, it is not like what you seen in the movies, like it will be walking something. Even if you make any small application, mechanical arm which can automatically pick and place. That is also can be called as a robot. RFID, radio frequency identification tags, which we have seen in the examples what used to demonstrate how the industry 4.0 works. RFID consists of chip and antenna. The chip will contain all the information related to the productions, which steps needs to be completed. The machine will read that RFID tag wirelessly even without visual contact. Then it will adjust itself for the next production step based on the information provided on the tag. Remote control systems. Most of the industries are connected their SCADA system to their central office via internet, from where the operators can able to monitor the status of the equipment and control the critical parameters from remote. And also these remote control systems help us to get a alarm messages or warnings by email or SMS whenever there is any abnormality occurs. This will help the operator or the maintenance person to take action promptly, avoiding the serious damage of the equipment before it goes to the breakdown level. Just imagine if you are a maintenance manager of any production plant, and if when you are not inside the plant, if some machineries goes wrong, and if you are able to get a message or alarm saying that so and so machine has been having so and so problem, then immediately you can get connected with the people available in the plant and you can guide them what needs to be done further so that they can able to resume the production as early as possible. And also these remote control systems, because we are avoiding the breakdowns, we can save the costly repairs, further its repairs and operating costs, lower our operating cost. Predictive maintenance. You might have heard about the breakdown maintenance and preventive maintenance, but now we are talking about predictive maintenance. As the name says, we are going to predict the condition of the equipment. We are going to predict the life of the spares which is running inside. For an example, if you have a bike, you will be replacing the engine oil regularly, right? For an example, if you are not change your engine oil and you are using your bike as it is, and after some time it will start giving some engine noise, you will be able to have some abnormal noise from engine. Then after getting that abnormal noise, if you take your bike to the mechanic shop to replace the engine oil, that is called the breakdown maintenance. You are allowing the machine to have till it gives some abnormal, whether it can be a sound, whether abnormal heat, abnormal vibration, anything, some abnormalities. After seeing some abnormalities, you are taking some action. That is called breakdown maintenance. Then preventive maintenance. Instead of waiting till the machine, till the engine gives the abnormal sound, you have noted down when you have replaced the engine oil last time, and you are maintaining, okay, it is already run for 1500 kilometers or 2000 kilometers. So you are voluntarily taking to the mechanic shop and you are replacing the engine oil. That is called preventive maintenance. The drawback of the preventive maintenance, that when you take to the mechanic shop and he will open the oil, then he will tell, sir, oil was good, you might have been used it for further 100 kilometers, further few hundred kilometers, but as already you have drained the engine oil, you will be putting a new engine oil itself. So it is an, you are replacing the spares even though when the existing spares has some life, it will lead to your inventory cost or maintenance cost. So to avoid that, now industries are moving towards predictive maintenance. Just imagine if you have a sensor which will give the condition of the engine oil to you, to your smartphone application or something. So you will be just keep on monitoring whether my engine oil is good or bad now. So you will replace the engine oil only when it is been necessary to replace. So instead of replacing at 2000 kilometers, even you can replace the engine oil at 2500 kilometers sometimes. Sometimes at 2000 kilometers or before 2000 kilometer itself, maybe because of some rough handling, if the engine oil quality, because of engine oil quality or something, if you are the engine oil has been deteriorated, then you will be getting a warning, that warning, or you will be getting information so that you will replace the engine oil as soon as you get a information from the sensor. about the quality of the engine oil. So that is called the predictive maintenance. So for having a predictive maintenance, there will be a sensors which will be sending a data continuously to the system. By analyzing that data, we are going to analyze the usage, wear and tear conditions of the and comparing with the characteristics of it, then we are going to predict the error. This will enable the service departments or service maintenance person to react promptly, by which they will replace the spares at right time, by which they will be able to save on the operating cost and inventory cost. These are the few technologies of Industry 4.0. Why we are talking about Industry 4.0 now? Why it is relevant today? Because there has been a pressure on the industries due to more product variants, due to the innovation cycles becoming shorter and shorter. You might have seen maybe 5-10 years before, you are getting a new model of mobile once in a year, new model of car once in 2 to 3 years. But now we are getting new model of mobile every month, we are getting a new model of car every 6 months. How it has been possible? It's because the complete innovation cycle, starting from design, testing or simulation, then going for a real production and making a real product out. So the complete innovation cycle has become shorter. Irrespective of what kind of industries it is, there will be some common question like how to increase my speed, how to increase my flexibility, how to increase my quality, how I can make my process and production line to run efficiently. So the automation suppliers like Siemens has been providing the answers for that, so that the companies to be remain competitive, they will be implementing the Industry 4.0 solutions to increase the speed. In other words, we can say it as and reduce the time to market. Means how I can have my shorter innovation cycles, how I can have more complex products which can handle larger data volumes. So having a integration of product and production processes, I can able to increase my speed or reduce time to market. Increase flexibility, how I can able to produce the mass production, but same time how I can able to customize it, how to change my product as per the volatile markets with high productivity, for which we may have to go for the flexible production. To improve the quality processes with feedback, traceability and integrated spare parts or raw materials, by which you will have a full process transparency to have the consistent quality. To increase the efficiency, we have to use our energy and resources effectively by deciding some competitive factors, by which we can able to achieve optimized production resources. All these things along with the cyber security, which is now very much needed as on today. Where do I come across Industry 4.0 at Siemens? So what is the solutions the Siemens is providing for the Industry 4.0? For that, I would like to play a short video. Maybe now just you have to correlate. There is nothing here to for a college students to know now, but you just try to understand how the industries has changed their way, how it used to work before, right? And for which now industries are working at this level. So for that, what are the skill sets or what are the knowledge which I need to upgrade myself, so that I will have a better job opportunity.
The world has changed a lot over the past few years. Today, you can configure and order electric scooters online and name your preferred delivery date. It's faster, more personalized, yeah, the things we like to do for fun. major challenges to companies all over the world, from personalized production to mass producing one-off items, and getting new products to market with securely and flexibly, of course, delivering exactly what the customer wants with consistently high quality at affordable prices while always looking for new ideas to generate more business. This takes true entrepreneurial spirit and a whole lot more. Product development, automated production processes, and digitalization must go hand in hand in order to create a company that can do all this. In other words, a true digital enterprise. A digital enterprise? Agriculture needed to do these things. Great. What does that mean? It means looking holistically. The products, machinery, processes, the entire plant, complete production, and the way everything performs. Not just the hardware, but most of all the data models and software solutions. Only by combining, processing, using, and continuously optimizing virtual and can you come up with something new, something better. This is what we call the digital enterprise. Beneath this, Siemens. We do equally well in a variety of whether this or assembling cell phones, airplanes, or cars. Why is Siemens so good at this? Siemens has mastered the principle of digital, which means it has something special to offer. Picture this. You want to produce a new soft drink or modify an existing recipe. Okay, the first step is to experiment with them and then simulate, optimize, and test digitally across the board. Of course, your drink needs a cool bottle and an eye-catching label, both of which you can also design digitally. You can then use this data to simulate the bottle and enough, all without having to build expensive. Since you're happy with your product, you have to plan its production. To use and with which functions? How do they existing equip? How do you organize the flow of goods, employees, workflows? You do all a process called the digital twin of production. It's faster and more efficient, and of course, there are also fewer errors once you switch to the real world. You can transfer information, tests, and processes to actual machine or plants with the press of a button. We even have cool technologies that let you digitalize existing factories. And of course, we have an automation portfolio like no other. Siemens calls this
totally integrated automation,
because everything is interconnected and therefore delivers huge quantities of valuable data. Totally integrated. So now production is up and running, and we are creating a tremendous number of wonderful products and generating lots of data, which must, of course, be protected. The digital twin of performance is our term for all operating and production information, as well as information about the finished product. The good and sometimes the not so good data flows virtual product and production planning processes, thus continuously optimizing the entire system. We have cool cloud-based analysis tools and trailblazing new technologies that keep making everything better and more transparent. Know where to start? Don't worry. Siemens has digitalization service experts who can guide you on where and how to take the first step. Once you have built a digital enterprise, and that means that everything will now be much faster, more individualized, and have the highest quality. It's good for customers, and it's good for the industry. To sum it up, a multitude of software tools and products must, of course, all work together, and Siemens has a name for this: digital enterprise. No one else can offer this, really. And suddenly, when you hear someone say,
realize your digital transformation now,
it all makes perfect sense. the digital enterprise. Only we have it.
Siemens. Ingenuity for life.
I hope that video gives you a fair idea for you to understand how the digitalization has been impacting the production technologies, how the industries are changing the way how they used to work before. So at this point, I will pause and I will allow the mic for the attendees. So if you have any questions, feel free to ask before we proceed further. Even you can feel free to ask your questions in Tamil also, as we understand that Tamil. In Tamil questions கேட்கலாம். Just at least up to this point, we have seen what is the role of PLC in how to make the process automated, why we have to use the PLCs, or what are the other options we have, and what is the advantages of using the PLC. What is Industry 4.0? What are the other industrial revolutions, previous industrial revolutions? What are the various technologies of Industry 4.0? How the Industry 4.0 is been implemented into the industries. I hope up to this much it's been clear for you. Industry 4.0 is a vast topic. We cannot able to cover it in 1 hour, but at least we can able to give a outline, a fair idea about what it is. Please unmute only if you have any questions. Otherwise, please. Okay. I will take silence as there is no any questions, and we will. I will take this silence as there is no any questions from your side, and we will proceed further now. Just give me a moment. I will be sharing my screen. Before that, I would like you to give your attendance. I will be sharing the attendance link in the chat box. Just give me a moment. I'm just sharing the link in the chat box. I request all the students to please mark your attendance. If you have any difficulties in accessing that form, please let me know. Okay, we will proceed our. Siemens is not only having a solutions for the industries on providing a industry 4.0 with products and the softwares. Even we have solutions for the industry 4.0 trainings. In Siemens, we have a dedicated division called CITRAIN, Digital Industry Academy, which will take care of all the training requirements of our industry customers, of our own employees, and now we are being giving a trainings to the college and university students.
We're actually constantly learning. Conscious and error, sometimes because we have to, but mainly because we want to. You can learn anything. That,
that, or that. But maybe not that. We learn new things because or simply to become better. And that makes us happy. And knowledge isn't abstract. You can see it, hear it, even smell it. Knowledge is individual. We decide what, how, when we learn, and where we learn. But who do we want